come you want to do?
So, hey, today, today, for everybody in here, we're going to take a few notes today. I got about 3 problems on the board that I want to walk through. Once we're done with those, you do have homework today. It's your last assignment of the year. Last assignment, other than our practice guide, but yeah, but we do that one together in class. What? No. So, alright.
If you give them a hug, you get extra credit.
So, okay, let's walk through our examples today. We're talking about vectors. Okay, alright, for vectors, let's do the first one here. Okay, I've got 3 problems I'd like to walk through today. First one is called vector W, a 3i plus 7j. Vector V is a 4i. Vector Z is a I minus 2j. And the question that they want you to do is they want you to sketch. They want you to find the sketch and find the final positional vector.
Do we have to find
the sketch and the final find the position vector of the result that they're going to ask for. So you have to sketch it and find the final result. Okay, this will require that you know kind of how this works. So this is the problem they want you to do. They want you to go 2w plus v minus z. So that's the problem that they want. So this is the problem we're going to actually work on. This is the first problem out of 3 that I'd like to do today. Okay? So the trick is to actually draw where this thing's going. Okay? You can attach these to each other and in such a way that you can get to your final result. So here's the concept. For 2 w's, w is going over 3 up 7. 1, 2, 3, 4, 5, 6, 7. All right, so here's w. Right? What we're going to do is we're going to double it, which is up here. This is 2 w's attached to each other. And then we're going to add a different vector on. Now the different vector that's in the back, it's going some other direction, right? Wherever that thing's going to go, we're going to figure that out here in a second. Wherever that vector is going to go. That's this part back here. This part you have to find kind of separately to figure out what that vector actually means. Okay, the vector v minus z that we're going to attach, it's going to go either here, here. It's going to be in some form where it's attached to this 2w to figure out the final position. We have to actually figure out what that is by itself. Okay, so v minus z. If we draw a rough sketch, what v is doing? V is going 4i. So it's going over 4, and it's not going up or down any, because this is a 0j on it.
I bet you go like this.
Okay, and the next one is a minus z. Okay, so this is v here, and we're going to go a negative z. Negative z is doing the opposite of this thing. So z normally goes up 1, back 2, right? So it would go up 1, back 2, over 1, down 2, I should say. Jeez,
what?
This is the x number, so this is an x, this is the y, so I'm actually going over 1, down 2. So this is where z would normally go. But the problem is I'm not going z, I'm going negative z. So that means I'm going the complete opposite of this one. So negative z means this. It means negative 1i plus 2j. So the trick on that one is going down, or I should say back 1 and up 2. So back 1, up 2 spots. And so this is negative z. Does that make sense how it's attached?
Yes, sir.
Okay, from the end of v. Now, why this is important? Why am I drawing this separately than over here? Because this part in the parentheses, going over v, back z, will give me what this drawing is doing. This drawing is v minus z. And that trick, by looking at that, that's going like over 3, up 2.
Yep, that's exactly.
Okay, that's the idea. So it's going over 3, up 2. That's what I'm going to do from here. I'm going to go over 2, up 3, and the idea is that it's going to be up here somewhere, but that's where the vector is going. So my final answer, like the final, where they want you to draw the sketch, the final result of doing all of this work is starting here at the origin and ending at the end of that final array where it's
Goofy looking drawing.
Question, do we have to get like an equation for that one, or just like draw it?
We're drawing a sketch, and then the final thing is we have to find the position vector. So that means we want the final answer for it. So like what the coordinate is in I and J component form. Yeah, so it's not really a formula, it's just like they call it the component.
Do you just add that vector and the other vector together?
Yeah, basically. So here's the trick. We're gonna figure out the answer for this, and just add it to 2W's, right? So 2W, so 2 times W, which is, W is the
6i plus 14.
plus 7J, so yeah. So this is 6I, 14J, right?
Add
So
that.
that's 2W. We're gonna add it, we're gonna add that to these two's being subtracted together.
So
Well,
3i plus 2.
yep, V minus Z, V is 4I, and Z, a negative Z I should say, was the negative 1I plus 2J. So here's the trick. Since I have both, I'm just going to add these two together, since I already have both numbers. So this is going to be a 3I plus 2J if I add those together. That's adding the V and the negative Z together. And now the final result is adding this red part plus the blue part, which is the 2W's. So I'm going to add these two parts together. So that's this piece right here and this piece, because those are the parts I need to
6i
add
plus 14j.
No,
Or
9.
9i, sorry, plus
9i. Yep.
16j sharp.
So final answer, 2W
Equals the
minus, or plus V minus Z, which eventually equals 9I plus 16J. And that makes sense for my drawing, that it was going over so many, and it was going up quite a bit, but I'm already at, 9 comma 16 with the final drawing. And so this part right here, this vector, is the 2W plus V minus Z. Questions with how I did a sketch and how I figured out the answer? I think it's pretty easy. If you just think of them in terms of like variables, like I's and J's, like you could just do it like Algebra 1 and not really have to think about it.
You won't have to draw the picture.
Yeah, the picture's the only tough part. You have to like kind of like figure out how it attaches and how it works. So that's gonna be a part of the homework today. They're gonna
That's
have
just
you
the
sketch.
answer you need at the end?
Yeah, so that final 9I plus 16J, that is this second part, which is the position vector. It wants to know like the component form of
Why
it.
would we have to sketch
And
that?
the sketch just guarantees that that answer makes sense. That it was going over so many and up. Some of the answers, I think there's 2 that they want you to sketch.
How did we
That's
get
what they want.
2W?
Imagine if they were me.
Okay.
They gave, this is what they gave me originally. This is the problem they wanted me to sketch. So they usually give you like all of this in the instructions, all of this stuff up here, and then the idea is that this problem would be like problem number 10 in the book. Make sense?
Yeah.
Okay, all right, last thing here. Last thing that I want to do here. We have 2 problems. The next 2 problems are pretty basic. Bless you. One is doing component form with trig functions. The other one is doing dot product. Okay, but does everyone have this problem written down?
Yes.
So you let me know when you're good, and then we're gonna move on to the
I'm
second
fine.
problem.
Draw C is not quite.
It's stupid.
We don't get it.
Keep going.
Or no?
We need another 12.
All right, moving on.
What, Amanda? You don't deserve a bag anymore. You have mono.
I can't just like miss lunches.
You can. Probably not a good idea.
All right.
Oh my god. I don't know what that
Okay, here's second to last problem today. This one we I think we did yesterday for the first time. Okay, magnitude of vector v is 14. The angle that we have is a 240-degree angle.
She said it.
Okay, now what this stands for, what they say in the instructions on this particular problem, they want the component form or the positional vector form of vector v given its angle with the x-axis and its magnitude. And they want us to find the I and j component form, right? So the idea is that how this works is to find each component, because we know it's going to be vector v. We know that. It's going to be something I plus something j. We're just trying to figure out what these numbers are. Now, to figure this out, this is the shortcut that I told you yesterday. That when they give you angles, to figure out the x component, to figure out the I component, right? So I know 240 is down here, right? This is where 240 degrees is going. 240. So if I need to figure out the x number, I'm basically taking the cosine of the 240 and then using the magnitude. The magnitude is the actual length of the vector. This vector is 14 in length. That's basically the hypotenuse of the vector of this triangle. So I can actually figure out what that length is, because if this is 240, what's the angle inside the triangle?
60.
60. Because, again, how I know that, when you're bringing it back to the x-axis, you subtract it from 180. So that's why that's a 60-degree angle. Well, this
And then
is
that's 90.
yeah, it's a 30, 60, 90 triangle. So we can figure out the numbers either using SOHCAHTOA or doing the actual the shortcuts for how I think they call them the special triangle
Wait, how do we
substitution.
know that's 14?
Okay, they gave me that.
What does that mean?
This is magnitude. It means the length of your vector. It's the hypotenuse, basically. So what I do, the easiest way I do this problem is I do it like this. I take the cosine of your angle, which is in my case the 240. I'll plug that here in a minute.
Why can't you just do 60?
Which I can do 60. We'll do the same thing. It's the same number. It's just the only difference would give it a negative sign. So I'll show you that here in a second. And then the hypotenuse would go on the bottom, right? Well, here's the idea. This hypotenuse is the actual magnitude of your vector. This angle is the 240 or the 60. Now let's do the 60, right? 60 is easy. So we'll do the 60. Okay, for 60 degrees, cosine, if you actually look at cosine of 60, it's 1/2 on a calculator. It's like 0.5. And we know that the magnitude of v is 14. So if we multiply this across, we get 7 times half, which is 7. Now, here's the problem. It's negative. Because you're actually in the third quadrant.
And he goes SOHCAHTOA.
And yeah, so the idea is that this is actually going to be a negative 7i. That would be the only problem that I would have with doing 60 degrees versus 240. 240 on a calculator would actually give me the negative number, which would be the correct answer. Now to figure out the y number, or the j number I should say, you're doing the same thing, but now you're doing sine of your angle. So is the y component over your hypotenuse, which is in my case the magnitude. Okay, and I'm going to use the same 60. But now sine of 60 is this. That's the sine of 60. It's a cross if you use your special triangles. Question? Yes. So we multiply the 14 across, and if I multiply the 14 across times the root 3 over 2, I get 7 root 3. Because the 14 would divide by 2. And it would be negative. Now, if you want to give me decimal forms, I'm fine with that. I'm just showing you the exact answers, what they would be. Because most people, if you just typed in 240, typed in sine in your calculator, give you a decimal, then you just multiply by 14. That would be the number for 7 root 3. I'm just showing you what the back of the book would show. Now, knowing that they're negative is because of this. I found the x number, I found the y number, and that's the component forms. We talked about those yesterday in class. That was the problems we did. Questions, comments about that? Okay, we only have one more problem today.
Yes.
One more problem, and then I'll give you your homework. All right. Okay. Hey, last problem here today. Last problem before I turn you loose on homework. Now remember, the last 15 minutes today, we're going to go over the 3 problems on your practice guide, which I need to hand out here in a second. So you're not going to get too much time today, but I'll give you plenty of time tomorrow and the days after. We only have a few more notes this week.
Tomorrow we're supposed to do about special tests for Friday.
Monday is mostly all special
We're gonna get it
tests.
all done on Monday.
Yeah, we'll get it mostly done. We'll do 3 tomorrow, 3 Friday. It's pretty easy, and then we focus on the rest of it. Tomorrow and Friday we just do a couple extra notes and we're done. So it's easy.
And then what are we gonna do for the rest of after?
We check scores, and then we sign out credit.
And then we can just hang out, eat some ice cream.
So, alright, hey, last problem, here we go. Last problem of the day, 2i, 4j, w is going to be a, let's go with a 5i
11J.
plus 11j. Fine, that'll work. Alright, so let's say that this is my problem, right? And the question is on this one, this is your last problems, they want you to do dot product between the two vectors, and they want to know the angle in between. So this is how you find the angle in between. Okay, these are the two numbers. These are the two formulas. The dot product formula is in that formula. So that's why we have to talk about how to find dot product, because when you try to find the angle in between the two vectors, that's what you have to do. Now, what I mean by the angle in between. If you're to draw these two vectors separately, like not attached to each other, but from the origin going their own way. So this is going over 2, up 4. So that's going this way. The other one's going over 5, going up 11. So this other one's going like way up here, right? There's an angle between them. Now, for me, it looks really small. To find that angle, we have to use that formula. So here's how it works. To find dot product, you multiply these numbers together, the i's and j's, and you add the two answers together. It's a number, it's a digit. So this is 10 plus 44, which is 54. Does everyone understand how I did dot product? You multiply the i's, you multiply the j's, you add them together. If they're negatives, fine. Add them together, it's a negative number. That positive number, 54, tells me it's going to be an acute angle. If it's negative, it'd be obtuse. If it was 0, it'd be a right angle. Like
Here, wait, whoa, let me write that down. What are you doing?
positive is acute.
I wrote that in.
Negative 0 is a right. Negative, positive.
Obtuse.
Negative is obtuse.
And then 90 is 0.
0 is right. What does that mean?
That's the angle in between.
Oh my goodness.
So this number, since it's positive, so my angle in between them is going to be acute.
Yeah, I'm trying. No way.
Okay, alright, we add them together. Now, we still have to finish. So here's the idea. This 54 goes here. It's not my final answer. It's just the dot product on my formula. The next couple parts.
Why are you the way you are?
Hey, shh.
What?
So, to do dot product, or to do magnitude, I should say, to find magnitude of V, okay, to do magnitude of V, I hope people are paying attention because this is on your semester test. If you know that.
Magnitude of V.
Okay. All right, magnitude of V. You actually square both numbers and you add them together. So the square root of V, which is the second one here, that's going 2 squared plus the 4 squared. So this is 4 plus 16, which is the square root of 20. Okay, so that part's V. Doing the W part, finding the magnitude of W, that's the length of W in terms of length. You square both of these numbers and add them together. So magnitude of W is 5 squared plus 11 squared.
25 plus 1.
25 plus 121.
What's the math, Mr. Ward?
146.
You memorized it prior.
Yeah. See, I made up numbers.
I made them up.
All right.
Lars and
So now, actually multiplying these out, and then taking the inverse cosine of this. So multiplying that out, that is a 0, 12 carry a 1, that's a 9, 2. Cosine
That's crazy.
over 54. Hopefully that's right. Let's make
That's the
double check.
answer, yeah.
Okay. And then we have to take the square root of that number and then divide that number over. So now, taking this number and dividing it over on a calculator, you're going to get 54 divided by that square root, which is 2920, and that's going to equal your cosine. And what you'll have to do is take the inverse cosine of whatever that decimal is. That will be a crazy small decimal, and you're going to take the inverse cosine of it. So let me type this in here. So 54 divided by the square root of 2920 is like 0.99999. So 0.99999. 1.99314 blah 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 blah. And we take the inverse cosine
Which is?
of that. So inverse cosine of 0.9993148.
It's really small, isn't it?
2 degrees.
Boy, is that today? Wow.
And I said it was going to be kind of small. They're basically going the same direction. This was a 2 degree angle.
That's crazy.
2 degrees. It was small. That's why I was going to pick a negative number, but when you said 11, I was like, all right, we'll go the same direction.
Makes sense. I think it's right.
Negative would have put a bigger angle in there. It'd been easier to calculate. All right, homework today.
This assignment.
This is your last assignment of the semester.
Well, I mean, we have to turn in our
Practice guide, but we do it in class together. So, all right, here we go.
You're not in class, where are you?
Last assignment. This is due on Monday.
Monday?
Monday.
That's a 5 to 10 minute presentation.
Page
It's 2 degrees.
709. Numbers 1, 2, 6, 9, 15, 16, 25, 30, 32, 49. All right, these are all like drawing vectors, adding vectors together, finding the magnitude of vectors, finding the angles.
There's another
But
page?
the second page,
No, dude.
719, these are all the dot
This
products.
seems a little bit
Hefty.
3, 6, 17, and 18.
Okay, that's not bad then.
So, those are the dot product problems. 2 of them are just find dot product by themselves, like normal dot product, just the 54 in that case. The last 2 find the angle between, so you're going 1 extra step.
Will you read 709 like the numbers out?
1, 2, 6, 9, 15, 16, 25, 30, 32, and 49.
Would you read the bottom ones also?
3, 6, 17, and 18. All right, now in about 5 minutes, we're going to look at your practice semester test and maybe walk through 2 or 3 problems here.
Why are we waiting 5 minutes to do this?
I usually wait for the last 10 to 15 minutes. Why the
Did you leave one on Stapleton?
Yes.
Did you actually?
Yes.
Was it on purpose?
Why do you like that?
I don't like the little crease on it, so I like to.
You know what I don't understand? Why teachers wait until the last like week and a half to give us projects. Like that's Mr. Rapp.
Okay.
I'd rather do a chapter. Yeah.
Well, she told me this was gonna be hard. She asked me which one I prefer to do. If I
Okay. All right. Now,
60. No, 120. I don't.
it is 120. Now, here's the idea. You have to use the formula that's printed on your sheet. That will be on the semester test day. You have to take
Sweet
the
relationship.
radius of your clock, 6 inches, and you take that times the angle. The angle has to be in radians. Going from 12 to 4 o'clock, 12 to 4 o'clock, that is a 120 degree angle.
Oh,
Now, how we know that?
Convert.
It's basically taking a full 360, that's a full circle, but you're going 1/3 of that. Now, why I know it's 1/3? You went from 12 to 4, that's a third. If you just divide the numbers, 4 divided by 12. So, that's 120 degrees, that is a third of 360. But I have to convert that 120, because you can't use degrees. You have to convert it to radians, you have to take it times pi divided by 180. This is the number you're going to multiply on 6. So if you actually simplify those numbers out, you get 6 times 12 over 18 pi, because the zeros cancel out. You can divide this out, which is 6 and 18 divided to make 3, and then 12 divided by 3, which is 4 pi. This number, 4 pi, if you actually multiply and divide, this turns out to be somewhere around 12 point something. And that's in inches. That's like the exact answer. This is like the decimals, 12 point something. You'll have to type that in your calculator and actually figure it out. You actually type in 4 times pi. Question?
Can you write in a different color besides red?
Yes.
Can you figure out what 4 pi is?
Okay. We're good with 1.
Isn't it just
Is it 0.4 pi?
12.56.
There you go.
Is it
12.56?
Okay, we're good with number 1.
No, just wait.
Wait, tell me when I'm good.
You are
Back table's good?
good.
It's
Yeah, we're
12.57.
good. Wait, why would they have to be good?
Amanda.
You guys good?
Huh? Yeah. Oh, when you round up.
Good.
Okay.
Yeah,
you
we're
guys
good.
good?
Yeah, you did.
Okay, alright,
Take
moving
2
on.
minutes.
Why did
Alright. Next one, number 3, or 2, I should say, number 2. Okay, number 2. You just have to do SOHCAHTOA on this problem to figure out the distance. You don't have to do log, sine, log, cosine, or anything like that. So in this problem, this wall, this is my angle. This wall over here is the opposite wall. This wall is the adjacent wall. So if you think about like SOHCAHTOA, I'm probably doing TOA. The reason I know it's TOA is I'm using opposite and adjacent, O and A. So this is tangent of your angle is opposite over the adjacent wall, which is 630 yards. So what you'll have to do here is you're going to have to multiply this number across. Now, if the letter was on the bottom, the variable's on the bottom, you're going to have to do a little switcheroo thing. Because I know, like in class, we talked about what happens when it's something like this. Tangent of 50 over x. You know, and this is tangent of, let's say, 20 degrees. Well, if that's your case, if the x is on the bottom, you do a little switch here where you take the x and the tangent of 20 and you switch their spots. And you actually divide 50 divided by tangent of 20. But since your variable's on the top, you don't need to do that. You just multiply this 630 across. Because again, TOA means opposite over adjacent. Second letter's on the top, third letter's on the bottom. Okay, it's going to be a big number because that's 630 yards, so yeah, it makes sense. Okay, questions, comments?
Here, wait 1 sec.
How was your day?
Good.
Okay, did you get it?
Okay, let me know when we're good.
We're good.
Let's rock and roll.
What's the answer? 528.6 yards.
Okay, we're good? We're good? Moving
Oh,
on.
the next one's -3, -4, or 5.
Alright, the last one on this page is doing SOHCAHTOA, but you're going to find all the remaining trig functions for this triangle. They're trying to explain this triangle's in a very specific quadrant, so you have to draw it in that quadrant and figure out all the remaining trig functions. One's already given to you. If you get cosine wrong, there's no helping you. Cosine's literally printed on that page. Okay? So you actually already know 2 of them. You know cosine,
Sine.
and so that's -3/5, and you know it's secant, which is the flip of that, which is 5 over -3. You should not get those 2 wrong. Those are the reciprocals of each other. Okay, no, the reciprocals will not be on the board. You have to know. Now,
Wow, that's a lot to know.
but you have your property sheet which you can use. Your
Wait, cosine, secant.
So now, to find the other ones, you're in the 3rd quadrant, like this. Cosine in the 3rd quadrant, why it tells me that. And if it doesn't tell you explicitly, you have to use the hints and tips. Like it might tell you like, oh, this one's positive, this one's negative. You got to figure out which quadrant you're in. Cosine is the adjacent over hypotenuse. I do Pythagorean theorem. I figure out this is -4. Again, you have to do Pythagorean theorem on your
We're so good
own.
at this.
And now you can figure out all the rest of them. We can figure out sine. We can figure out tangent. I'll figure out sine and tangent for you.
-4/5.
Okay, -4/5. Tangent, positive. Tangent is opposite over adjacent, which is 4/3. And then the reciprocals are cosecant
Those are both
and
negative.
cotangent.
Those are
So, okay, notice. 2 of all the trig functions, all 6 of them are positive. 4 of them are negative. That's usually how it works if you're in any other quadrant other than 1. If you're in the 1st quadrant, everything's positive. I'm checking negative signs. I'm checking what numbers you have. Are you canceling out negative signs? All that good stuff. You have the remaining 5-6 minutes left of the class here. Whatever you need, you can work. Tomorrow will be basically a very large work day. We only have a few notes to take tomorrow to talk about why I did all that vector stuff. We'll do a few notes on the board. I'll give you a lot of time to work, and then the last 10 minutes, or maybe you want it at the beginning, we'll talk about the 3 problems on your semester guide right away, and you can have the rest of the time to work. Tomorrow's just a big work day.
Thank you, Mr. Ward.
So just be ready to go tomorrow. We'll take a few notes, which are very few.
Midlife